All right, let's talk about functional dependencies. So, we've been mentioning the fact that we want to make sure that we don't have any redundancy in our database. That um, that if we query the database in two different ways, that conceptually should be the same. Then it should be that we have to enforce the fact that this is indeed the case. So we want to make sure that whatever design we come up with, right, it's not causing any redundancy. So how do we identify these redundancies, right? Some of these redundancies might be very, very subtle, right, and we don't realize that that's in there, right? Um, so for instance, one of the classical ones is that you might have three fields where one of the fields is the first name, the second field is the last name, and the third field is a full name, right? And so certainly the full name is dependent on the first name and the last name, right? So ideally, conceptually, the full name should be the concatenation of the first two, right? And so that this third field actually could be computed from the first two. There's probably not even a necessity to even keep track of it, right? That you can always on the fly calculate it, right, and always get the full name. So that third field, which has a dependency on the other two, right, is what sometimes we refer to as a functional dependency, right? That if one changes, then the other one also has to change, right? That one depends on the other, right? So we need to be able to identify what these dependencies are, right? And whenever we find a functional dependency, we must try and eliminate it. Okay. Now some dependencies are okay, right? For instance, if you depend on a primary key and only the primary key, well, that's fine because that primary key is unique, right? So there's a so we say that a good data model is the one that only has data that depends on that one primary key, right? That meaning that if the key is primary is unique, that data is unique. Right? There's no other place where you're going to find it, right, in this table, right? That you can find that information, right? Um, so we're looking for these redundancies, certainly in the relational model and in the object model. Unnecessary attributes or properties or constraints that we didn't find. We want to identify what are referred to as functional dependencies, meaning fields that perhaps might depend on other fields, right? That those dependencies are hints that you have redundancy, right? So we want to identify those functional dependencies. If we find them, it says, ooh, these fields actually depend on each other. There might be redundancy within the same record. Right? We want to remove those functional dependencies. So if here's an example that we have a student that is in a semester. It says, notice that you have the student ID and we have the same semester. If for instance, if I know the student, I know what semester they're in, right? So by knowing the student, I know what the semester is, right? Because that student can only be in that semester, right? And so we say that the semester is a function of the student ID, right? If I say that this professor always teaches this course, right? Then you're creating you're expressing that there's some kind of dependency between this professor and that course, right? You say, well, if you know the professor, you know what they teach, right? So what knowing about a particular field might tell you about some other field, okay? And we often capture it as a functional expression, right? That if I know one of them, it's a functional representation of the other, right? If I know one, I can always calculate the other. If I know the first and the last, I can always calculate the full name, right? Here's another one that if you know the student ID and you know the particular lecture, then you know who the TA is. Or you might also know that a particular lecture or a particular course is only taught in a particular semester, only in the fall, or only in the spring, right? And only for sophomore, or only for freshmen, right? And so knowing all these rules, right? Then you can imply or infer, certain things about the data, right? That if I know your semester, right, then I probably know that you're taking fundies, and you're taking these courses, right? And oftentimes these dependencies are somewhat, uh, um, they're very nuanced. Right? You don't see it right away, right? And you probably have in your database that you're capturing all this information. The person is in this semester, and this is the course that they're taking. And says, well, wait a minute. If I know what semester you're in, I already know what courses you're taking. Don't capture that, right? Because it can be calculated elsewhere, right? It's probably captured elsewhere. Right? Do not capture it twice. So formally, we say that there's a determinant set and a dependent set, right? A certain number of attributes that might allow you to calculate some other attributes. That if you know certain attributes, it will imply the values of some other attributes. So there's a dependency between the two, right? Again, always going back to the example, if I have first name, last name, I can calculate the full name, right? That if we entirely know certain attributes, we can calculate the value of other attributes. So there's a relationship between the two. Okay. So let's take a look at some constraints that we might add. For instance, a professor can only teach one course. So a professor can only teach one course. That's certainly introducing a functional dependency, right? If that requirement wasn't there, right, and you had in your table that said, well, this professor is teaching that course, and they're also teaching this other course over there, right, and all of a sudden somebody introduces this requirement and says, oh, wait a minute, now all my data is bad, right, because I had a whole bunch of professors teaching all sorts of different courses. I am breaking now this rule. Okay, so I want to identify what these dependencies between professors and titles and courses that they teach, and see if I'm breaking any rules, and if we can enforce them, or if I identify some dependencies, I'm saying, well, if I know something, I can always calculate the rest. So, for instance, um, uh, before any of these rules, my data might have looked like this. Einstein, they're teaching physics, dance, physics. It might have been fine. There's nothing wrong with Einstein teaching dance. But somebody might add certain rules in there and say, for the same value of professor, you have to have the same course ID, right? For instance, for the professor, for instance, now if I add that rule, knowing the professor, right, I certainly know what course they're teaching, right? It's redundant. If you tell me that Einstein can only teach physics, well, if I know Einstein, there's no need for you to tell me that's physics. Obviously, they're teaching physics. There's no need even to capture it, right? One implies the other. But if without that functional dependency, without that rule, right, then there is no dependency. They would be fine with Einstein teaching something else other than physics. Yes, right. Now, if by adding that rule, certainly this data is breaks the rule, right? So I need to remove it somehow. But even by removing it, I now have a functional dependency that was not there before, right? That by knowing the professor, I also knew what they were teaching. Right? So now there's a redundancy in my data that I could inadvertently misspell the name of the course, right? And I come from a different country, and English is not my first language, and it might start off with an F, right? And it's totally fine, it looks perfect to me, and I misspelled it. It wasn't my intent. I didn't intentionally do it, but there's no way to catch this. There's no way to catch the fact that I misspelled it, right? So now, the redundancy that was added by this new rule that wasn't there, now it gives me a challenge of how now I enforce this problem. How do I enforce the fact that they can only teach physics? There's no way to enforce it. So redundancy certainly gives us the risk of inconsistency, right? That I misspell the course, or maybe I say that they indeed teach dance, right? And the database wouldn't know, wouldn't complain about it, right? So we need to remove these inconsistencies, right? So we're looking for these dependencies. We're looking for all these left-hand side attributes that might imply values for our right-hand side attributes. Here's another one. All sections in a year must be taught by the same professor, right? Conceptually, we can capture that saying, if I know the course ID and I know the year that it was offered, I know who's teaching it, right? That's a functional dependency. And again, it's a rule, and somehow we need to enforce it. How do we enforce it? Formally, we capture it by saying, x1, x2, all the input attributes imply an output. They cannot be determined by data, right? Just by perusing this data, Einstein teaching physics, dance, and whatnot. I cannot. I don't know. Is that okay? Right? Not until I look at the rule. Not until I look at the business rule and the meaning of the data can I infer that that's wrong. Okay, so we cannot infer it from the data itself. It can only be inferred by the meaning and by the rules that and the business rule that are given to us by the requirements. A couple more. The requirement is that all sections professor teaches are from the same course, or course taught at most once a year. Those could be business rules, right? Those introduce functional dependencies that were not there. If I know the course ID and the year offered, I know which section it must be. Okay. So let's look at examples of some of these. All sections professor teaches are from the same course. So there it is: Einstein physics and Bohr also physics. If you know the professor and the year, then you also know who taught it. What are they teaching? What they're going to teach. If now you add me another rule, course ID and year offered is the same section. Now data that was perfectly fine is now breaking the rule. Again, we can't infer it from the data. That if you know the course and the year, then there's only one possible section that is being taught. Yes. So if you remember this, the super keys, right? They were uniquely identify the record, but a super key might have redundant or not redundant, superfluous keys that don't make it any more unique. Remember that? And we say that a super key that had non-redundant, superfluous keys, right? We just called it a key, right? The key. So in general, we would love to have instead of having. So the problem here is redundancy that is introduced when you have non-keys, right? That might imply other values. For instance, here where Einstein and physics, right? They themselves are not might not be primary keys, right? The primary key is here is student ID, yes, but these over here are not keys. I can enforce keys by making them unique. I can combine them together and say that these have to be unique, so the same combination cannot happen twice. But I can't enforce that on something that is not a key, right? So what I want to be able to remove is these kinds of redundancies, right? These functional dependencies of non-keys that can affect other non-keys. Right? Ideally, I would want to be able to enforce uniqueness and say, hey, if Einstein can only teach physics, hey, how about I make that a key, right? I can make that the key. I can say that the combination has to be unique, right? And now I can have the database enforce that rule for me. See that, right? So ideally, I would want to say, hey, actually, this functional dependency is kind of giving me a hint. It's kind of giving me a hint that those two fields, probably they should be part of the key, right? That I can combine them, I can make them unique. So I can use functional dependencies as a clue, right, of what should be my keys, so that I can enforce uniqueness, right, and enforce the rule, right? So functional dependencies can help us determine, right, what those primary keys should be, or what the combinations of those fields should be, right? The if you have functional dependencies of course ID and year offered is implying that the section ID, perhaps the combination of course ID and year offered, should be part somehow of the key, so I can enforce that uniqueness, right? Right. So it's giving me a hint that perhaps, right, this must be part of that key. So formally, we can say that we have a combination of keys that imply a certain other fields, right? That kind of tells us that those keys should be part. Those fields should not just be fields; should be part of the super key. And ideally, you would identify certain fields in those super keys that you might not need, and they might be superfluous, and you can drop from the super key and just keep only the key. Professor, so we call dependencies. We call dependencies that that establish a dependency between keys and the fields. We call them full functional dependencies, and those are dependencies that are between the keys and the fields, which are good. Those are the ones we're looking for. We're trying to remove any dependencies, any non key dependencies that are dependencies between fields that are not keys. Okay. Yeah. So we're looking for functional dependencies that are key based on the left-hand side. Right, so on the left-hand side, you have keys, which you can enforce constraints and say that those are unique, and those are the ones you want to keep. And there's going to be a segue into normalization, right? Into first normal form, second normal form, and third normal form, right? That are the formalities of trying to implement these types of relationships, these functional dependencies between keys and non-keys. The ones you want to remove are the non-key based functional dependencies. Those are clues that you are going to have redundancy, right? That you're going to have inconsistency, right? And you should remove them. And the way we're going to remove them is by normalizing the tables, right? And then we'll look at there's several ways to normalize the table, but the three more common ones are the first, second, and third normal form, which we'll see in a minute. Why these non-key based? Why do they occur? It's because we either forgot to remove a bad relationship, right? A redundant relationship. We forgot to remove it, right? And they make their way into the relationship, into the relational model. So let's look at normal forms.
Hi everyone, Jose here. Please remember to subscribe and like the video. And if you have any questions, please leave a comment down below. Thank you.